So here's a second order linear differential equation. Y prime prime makes it second order linear. But the target function, the forcing function, is a split function. It's -4 before pi seconds and then it's 0 after. So the first thing I'm going to do is I'm going to write that using the Heaviside step function. So -4, and now this Heaviside step function is going to turn on. That highlighted U is going to be equal to 1 after pi seconds. It's equal to 0 before pi seconds. So inside the square bracket is going to be the function, the thing I have to turn on, and whatever it is, I need to add it to -4 to give me the 0. So it's going to be 4. So before pi seconds, this U is 0, so the function is just -4 plus 0. After pi seconds, this U is 1, so it's -4 plus 4, giving me the 0. Now I'm ready to take the transform of this function. And I guess when I'm taking the transform now, I'm thinking of it in that format. I've written it on one line with the Heaviside step function. So now let's take the transform. The transform of y prime prime, I've got it down here, is s squared f. F is the transform of the unknown function. So here's my transform of y prime prime plus 4 times the transform of y equals, now the transform of -4, a constant, is going to be -4 over s plus, okay, Heaviside step function at pi seconds is e to the minus pi s. And now when we're going into the Laplace world, we need to, the function that's turned on, everywhere there's a t in that function, everywhere there's a t, I have to put a t plus 2, no, plus pi, yeah, plus pi, because that's when the step function turns on. Everywhere there's a t, I got to put a t plus pi and then transform it. Now, doesn't matter here, there is no t, it's just 4. So, but I have to think about that. Now let's transform 4, that's 4 over s. The initial conditions are both 0, so that makes these parts disappear. Y naught is 0, y prime naught is 0. And so here's the I'm in the Laplace world. Now I need to solve for f. So I see that I can factor out an f here. So f times, I've got the s squared plus 4, and that's an unfactorable quadratic. I want to see that as what my auxiliary equation would be if I was solving it in another method. So now I can solve for f by dividing both sides of the equation by this s squared plus 4, this unfactorable quadratic. So dividing both sides, and now I'm going to unLaplace, but before I take the inverse Laplace, I need to break this up into partial fractions. I've broken this piece up into partial fractions. I've broken, oh, I didn't have to redo the math because really the inside of this square bracketed piece is just the negative of that outside piece. So I could use the same partial fractions but just multiply through by a -1. So now it's broken up into pieces, and now I can unLaplace. Inverse Laplace of f, capital F, is y. Inverse Laplacing this one is going to be cosine 2t minus 1 for the 1 over s plus, okay, this e to the minus pi s, that's my Heaviside step coming back. And what's the Heaviside step turning on? Well, this function inside the bracket would normally unLaplace to be 1 minus cosine 2t. 1 minus cosine 2. But everywhere there's a t, I want to put a t minus pi because the argument inside the square bracketed piece has to match the argument inside the Heaviside step piece.